What's up, guys? Welcome back from your short break this weekend. It is Tuesday, April 14th. Like I mentioned last week, we kind of just made sure we have the skills for Chapter 10. And now today we actually are going to start 10.1. All right, and we're just going to focus on just kind of two specific things today. So in your notebook, real quick, let's write down our learning targets, which I'm actually going to bring up for you today. It's just one learning target, actually. Where we can determine the domain and range of a square root function. Okay, so in order to graph square root functions, we need to figure out what the domain is first. Let's review quickly what those two words mean. The domain is all of the x values that you can plug into the function that make it make sense. Okay, now what we know about a square root is we can't take the square root of a negative number right now. Okay, so that could kind of lead you towards how the domain is going to work. All right, and then the range is all of the y values that come out when plugging in our numbers for x. Okay, so what we need to do first is we need to determine what the domain of a square root function is, and then we can use that, plug in numbers, and find the range. Okay, those are the things we're going to focus on today. So let's start off by just reading. All right. A square root function is a function that contains a square root with the independent variable in the radicand, and the most basic square root function is y equals the square root of x, which they give us a graph of right here. Okay. Now what it means here, independent variable in the radicand, that means that the x is either the x or an expression containing x is underneath the square root symbol. Okay, that's what they mean when they say the independent variables in the radicand. All right, the radicand, that's just like a square root symbol. Okay, a radicand, that's a square root symbol. All right, now here's where it gets into domain and how it makes sense for our numbers to not be negative. So it says the value of the radicand in the square root function cannot be negative. So the domain of a square root function includes x values for which the radicand, or what's under the square root symbol, is greater than or equal to 0. All right, so there's a really simple rule that we're going to use for finding domain. So example 1 is just finding domain of a square root function. Okay, here's what we're going to do. Let's open up example 1. If we know what's underneath the square root symbol, which is right here, the x minus 5 is the only thing that's underneath the square root symbol. If we know that that can't be negative, what we can do is we can write an inequality saying that x minus 5 must be greater than or equal to 0, saying that what's under here cannot be a negative number. Okay, so to find domain, that's what we're going to do. We're going to write an inequality. Okay, so let's read this. It says the radicand cannot be negative, so x minus 5 has to be greater than or equal to 0. Okay, what we're going to do is we're going to say x minus 5, and we're going to say it must be greater than or equal to 0 with an inequality. We're going to write that out, and we're going to solve the inequality for x. Okay, by adding 5 to both sides, we solve this inequality for x. So what we just found, guys, is our domain. Okay, so the domain is the set of real numbers greater than or equal to 5. Okay, now why is that important? Because it tells us what numbers we're going to plug in for x in order to graph something like this. Okay, we would plug in numbers from 5 and on, anything greater than. Okay, so let's look at one more where we're just finding domain. Let's focus on that first. Make sure we understand it. All right, so here's our next example. Negative x plus 5. Okay, that's what's under my radicand or under my square root symbol. Okay, I'm going to set that greater than or equal to 0. Okay, so let's see if I can do this well. So negative x plus 5, we're going to say it must be greater than or equal to 0. Now this example is really important because it shows our rule of when we divide by a negative to get rid of this negative sign, we have to flip our sign still. Okay, so let's look at that. So let's solve this first for x by subtracting 5. subtracting 5. That leaves me negative x greater than or equal to negative 5. And again, to get rid of this negative sign, we would divide by negative 1. Divide by negative 1. Okay? What that does is it's going to flip this sign the other way. So my final answer would be x is now less than or equal to negative 5 divided by negative 1, positive 5. Okay, so this is our answer. This is our domain. Okay, x is any number that is less than or equal to 5. Okay, so let's just recall when we use inequalities, we divide negatives. We still have to flip that inequality symbol. Okay, let's see if you guys can try this quick. All right, so remember, we're only setting what's underneath the square root symbol, only what's underneath the square root symbol greater than or equal to 0. And then we're going to solve that inequality if necessary. What I'm going to tell you right now, I'm going to give you a hint. 1 and 2, do not overthink them. They are as simple as setting what's under there greater than or equal to 0. And if we can't do anything to solve, or there's nothing to move in order to solve, then we've already got our domain. Okay, so do me a favor, try these 3 real quick. So pause your video, and when you come back, answers will be up. All right, so let me go through that again. Okay, if we look at 1 and 2, guys, all that's underneath the square root symbol is an x. So we just say x, what's under there, is greater than or equal to 0, and we can't do anything else. That's the answer. Okay, that's our domain. So number 3, we could subtract 1 and divide by negative 1. We'd have to flip that sign, but we end up with x is less than or equal to 1. Okay, so that's how we find domain in any square root equation. Now let's look at example 2 to tell us how do we find or figure out what the range is now. Okay, so we're not going to worry about like actually physically graphing today. I just want you to see what the graphs look like. And again, I want us to be able to determine domain and range of an equation, because that's what you guys are going to do on IXL and be graded on today. Okay, so first I'm going to start out by finding the domain of this function right here. Okay, so what I want us to do is, I don't want you to worry about any of this comparing. All right, I don't want to worry about that. I just want to describe domain and range of this function right here. I'm going to worry about graphing. Okay, so let's look at what they do. They made a table of values. How did they know what to plug in for x? Here's how they knew. Here's how they knew. They took what's underneath the square root symbol, which is just an x, and they set it greater than or equal to 0 to determine the domain. Okay, so this is the domain. This is telling us what numbers to plug in for x. Okay, what do they do next? They go ahead and make a table where the first number they plug in is this number. Okay, is this 0. And when we plug in 0, we take the square root of 0 and we add 3 to it to get 3. Okay, now the next number we're going to plug in 1, because we could take the square root of 1, right? So we take the square root of 1 to get 1. We add 3 to it to get 4. Okay? Then they choose 4. They choose 9. They choose 16. Hopefully you're understanding why. Because those numbers have whole number square roots. They have perfect squares. All right, so if we took the square root of 4, we'd get 2. We'd add 3 to get 5. All right, so let's look at all these y values real quick so we can determine what our range is. All right, remember, this is the domain. This is the answer for domain. X is greater than or equal to 0. Okay, so domain is right here. Now range, if we look at these y values, after we plug in our numbers for x, and we look at these y values, what do we notice about them? They start at 3, and then they go up from there. Then they go up from there. Okay, so what I could say for my range, which are my y values, is I could say y is greater than or equal to my lowest number's 3, and say that's my range. All right, this is my range. Y is greater than or equal to 3. Okay, so we're going to review that real quick. We are going to start by finding the domain, okay, which was x is greater than or equal to 0. we're going to plug those numbers in, anything that's greater than or equal to 0. They chose smart numbers that have perfect squares, right? And then we're going to look at our y values that come out, and then we can write our range from there. Okay, let's try another one. Let's try another one. So for this right here, this function right here, first of all, what you should be noticing is, again, all that's underneath my square root symbol is an x. Okay, it's an x. So I'm going to say x is greater than or equal to 0, and that's my answer for domain right away. Okay, this is my domain. X is greater than or equal to 0. Now to find my range, I need to plug in numbers for x to find my range, to figure it out. Okay, so what I'm going to do is make my table. Might not be the neatest thing in the world, and I'm always going to start with this number right here. Okay, I'm always going to start with that number, and I'm going to choose a couple numbers. We don't need to go crazy. I'm going to choose a couple numbers, but I'm going to use numbers with perfect squares, and I'm going to plug it into this function right here. Okay, so let's start with, I'm going to do this in my head, hopefully you're listening. Let's start with plugging in 0. Square root of 0, 0 minus 6, that gives me negative 6 for y. When I plug in 1, the square root of 1 is 1, minus 6, that gives me negative 5. And when I plug in 4, square root of 4 is 2, 2 minus 6, negative 4. So if I'm focusing now on my y values, I start at negative 6, and then I go up from there. Okay, and then I go up from there. So I'm going to say my range is y is greater than or equal to negative 6. Okay, that's my range. I get my range from basically plugging in my numbers from my domain. All right, I'll show you one more. I'll show you one more, a little more complicated problem, and then I'm going to have you guys try this today. Okay, so once again, let's focus on, we're going to find domain first. Okay, this time I have x minus 2 under the square root symbol. Okay, I'm going to start by saying that expression cannot be negative. So I'm going to say x minus 2 is greater than or equal to 0. It has to be. All right, now I'm going to solve for x by adding 2 to find my domain, which is going to be x is greater than or equal to positive 2. All right, so here's my domain. Why is that important? Because it tells me what to plug in for x into this function. Okay, so at this time, I'm going to make my table and do my math. All right, and I'm going to start with this number always. All right, so my domain says to plug in numbers that are greater than or equal to 2. I'm going to start with 2 and work my way up from there. All right, and I'm going to choose these specific numbers, and hopefully you'll see why. All right, so I'm going to start with 2 and then go up from there. So let's do this. So 2 minus 2 gives me 0. There's no such thing as negative 0. Okay, so y is 0. When I plug in 3, 3 minus 2 gives me 1. The square root of 1 is 1, and then I pop this negative sign on at the end. Okay, that negative gets popped on at the end, so negative 1 comes out for y when we plug in positive 3. Now I'm plugging in 6 because 6 minus 2 gives me 4, and 4 has a perfect square. That's why I'm plugging in 6. All right, so 6 minus 2 is 4. The square root of 4 is 2. Then I pop this negative sign on. All right, and I get negative 2. So let's focus on our y values so we can just kind of determine what the range is now. All right, what is my range? My range is starting at 0 and going down from there. So my range this time is going to be y is less than or equal to 0. Okay, because it starts at 0 and goes down from there. All right, so my range is here. Y is less than or equal to 0. Okay, so hopefully that makes sense to you. That is all you are going to focus on in IXL right now. All right, so if we look at IXL and we go in here, this is going to be FF.3, which is domain and range of radical functions, meaning square root functions. Okay, we're going to be given equations. All right, so what is the domain of this function? The domain only. I see an x underneath the square root symbol only. Remember, it's going to be x is greater than or equal to 0. All right. What's the range of this function? The range. Okay, so in this case, we're going to have to plug in whatever numbers we get when we find our domain. Okay, so we got to find our domain first in order to find the range by plugging in the numbers from the domain. Okay. By the way, if we plugged in, let's say 0 first, we're going to get 0, and then the range would be 0 or anything greater than that. So again, the range here is y is greater than or equal to 0. All right. What's the domain of this function? I'm just going to show you this last one, and then we'll move on and have you guys try this. Remember, I'm taking what's underneath my square root symbol, which is 4x minus 20, and saying that that must be greater than or equal to 0, and then I'm solving it. Add 20. Okay, leaving me 4x greater than or equal to 20, and then I'm going to divide 4 to get my answer of x is greater than or equal to 5. When I divide 20 by 4, I get 5. So x is greater than or equal to 5. Okay, would be my answer here. Okay, so hopefully that makes sense to you. If not, as always, you can ask questions in the discussion thread, or you can email me at any time. But at this time, you are going to go into FF.3, and I will be taking a benchmark grade on this. Okay, so guys, what you can see here is in order basically to graph square root functions, we have to be able to find domain and range, okay, in order to do that. So that's why we're going to practice this today. Again, let me know if you have any questions. Otherwise, I will talk to you guys tomorrow.